On Earth, on ancient Earth, it never rained, but it poured. This is today's article by Harvard John A. Paulson School of Engineering and Applied Science. Today, we're experiencing the dramatic impacts that even a small increase in global temperature can have on a planet's climate. So now we can imagine our Earth 20 to 30 degrees Fahrenheit, more than it is today, or 11 to 17 degrees Celsius hotter than today. Earth likely experienced these temperatures at various times in the distant past and will experience them again hundreds of millions of years from now as the sun continues to brighten. Little is known about how the atmosphere climate behaved during those so-called hothouse periods. In a new study, researchers from Harvard University found that during these epochs of extreme heat, Earth may have experienced cycles of dryness followed by massive rainstorms hundreds of miles wide that could dump more than a foot of rain in a matter of hours. If you were to look at a large patch of a deep tropics today, it's always raining somewhere, Jacob Seeley said. He's postdoctoral fellow at Environmental Science and Engineering at Harvard John A. Paulson School of Engineering and Applied Science, SAES for short, and the Department of Earth and Planetary Science at Harvard, and first author of the paper. He said, but we found that in extremely warm climates, there could be multiple days with no rain anywhere over a huge part of the ocean. Then suddenly a massive rainstorm would erupt over almost the entire domain, dumping a tremendous amount of rain, and then it would be quiet for a couple of days and repeat. This episodic cycle of deluges is a new and completely unexpected atmospheric state, said Robert Wordsworth, the Gordon Mackey Professor of Environment Science and Engineering at SAES. He's a senior author of the study. The research not only sheds light on Earth's distant past and far-flung future, but it may also help understand the climates of exoplanets orbiting distant stars. The research is published in Nature magazine. Now, in an atmospheric model, Seeley and Wordsworth cranked up Earth's sea surface temperature to a scalding 130 degrees Fahrenheit, that's 54 degrees Celsius, either by adding more CO2, about 64 times the amount currently in the atmosphere, or by increasing the brightness of the sun by about 10%. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. At those temperatures, surprising things start happening in the atmosphere. When the air near the surface becomes extremely warm, absorption of sunlight by atmospheric water vapor heats the air above the surface and forms what's known as an inhibition layer, a barrier that prevents convective clouds from rising into the upper atmosphere and forming rain clouds. Instead, all that evaporation gets stuck in the near surface of the atmosphere. At the same time, clouds form in the upper atmosphere above the inhibition layer as heat is lost to space. The rain produced in those upper level clouds evaporates before reaching the surface, returning all that water to the system. Seeley said it's like charging a massive battery. You have a ton of cooling high in the atmosphere and a ton of evaporation and heating near the surface separated by this barrier. If something can break through that barrier and allow the surface heat and humidity to break into the cool upper atmosphere, it's going to cause an enormous rainstorm. That's exactly what happens. After several days, the evaporative cooling from the upper atmosphere's rainstorm erodes the barrier, triggering an hours-long deluge. In one simulation, the researchers observed more rainfall in a 6-hour period than some tropical cyclones drop in the U.S. across several days. After the storm, the clouds dissipate, and precipitation stops for several days as the atmospheric battery recharges and the cycle continues. Our research goes to show that there are still a lot of surprises in the climate system, said Seeley. Although a 30-degree increase in sea surface temperature is way more than is being predicted for human-caused climate change, pushing atmospheric models into unfamiliar territory can reveal glimpses of what the Earth is capable of. The study has revealed rich new physics in a climate that is only a bit different from present-day Earth. From a planetary perspective, said Wordsworth, it's raising big new questions about the climate evolution of Earth and other planets that we're going to be working through for many years to come, he said. This is by the Harvard John A. Paulson School of Engineering and Applied Science on phys.org. Please leave your comments and thank you for your support.